Okay, it has been well over 16 hours. In fact, we're at 17 hours now, 7:02 a.m. So, where are we at here? This thing is still running. It is down to 14 volts, pretty much straight across the board there. So, let's see what the ANOVA is going to tell me here. .99798 volts. So 13.98 volts. Okay, we started out at 16.5 volts and we've ran this for 17 hours. That's pretty good because I'm running 6 of these. I really want to determine how long I can run 1 meter on with these auxiliary batteries. So anyway, it's still not dead yet. It would get down to 12 volts and it'd be dead. So that was a pretty good test. These batteries are old and worn out. Their capacity is way down from what they used to be. So they're not exactly good batteries. But we'll run a test on an individual one of these at some point. And I am going to get all these other meters hooked up to this here eventually and test those against all these. So we'll leave that for now. We'll just disconnect it and we'll move on to the 12 volt 3S pack. Okay, the 12 volt 3S pack has been running for approximately 30 hours. Started out at 12.12 volts. Let's see what we have now. We have got 10.55 volts. So that's not too bad. So it's only used in 30 hours. It's only used less than 2 volts. So again, I doubt that I would leave this plugged in all the time. Not sure how I'm going to be using either one of these eventually, but I will eventually have one of those small little meters that we just looked at permanently connected up to this, or somehow I'll have it set up so I can disconnect it, because I wouldn't want to leave it for weeks and months at a time. So this is pretty much all I've gotten done today. I ended up with a bunch of chores around the house and didn't get everything done that I wanted to, but I did start dismantling the little testing station, and I've mounted 1 meter on each of the auxiliary battery packs. It's just glued on there. The proper way to have done this would have been to before I put all the Kapton tape on there, to have soldered those leads on there like I did the balancing harness. But it's too late now. I don't want to take it all apart. So I just kind of had to do it in kind of a half-ass way, so to speak. But remember, both these battery packs are basically throwaway batteries because every one of them are under 2,000 milliamp hours, all the cells. So they're really not any useful except for something like this. So it's no big deal. I don't expect to have these forever because they're pretty worn out, but they look like they're going to work. So I did manage to get this one charged up. It's showing 16.2 right now. I didn't get to charge it up all the way, but I'll put it back on the iMax here for a few minutes and try to bring it all the way up to 1655 is what it should be. And this one I didn't get charged up at all, but I got it finished and I can put this on the charger really any day when I'm home. And that's it, and we'll bring them up. They are permanently connected right now. That's not how I wanted to do it. I definitely want to put a very small, like male-female connection in here. I don't have any. I looked everywhere and I can't find any. But it'll be simple enough to simply break that wire right there and put one in. But I'm going to have to go pick some up on my way home tomorrow or the next day or something. But I thought this was a nice test to permanently hook these up, charge them up fully, and then just pack them away somewhere and let those little meters run and see what it does. See what a week with these things mounted on here does to my batteries. And unfortunately, I did not get to this today. I really meant to. I'm just out of time, unfortunately, so I've just got a great big pile of gauges and meters here that all need to be hooked up and tested against all these to see what they're doing, and tested against the ANOVA multimeter. So unfortunately, that's going to have to come probably on my next days off. So that is it for now. Okay, after sitting an entire week, both the auxiliary battery packs have been sitting connected up to the new little meters, and I've got it rigged up. I decided to just test the small little meters, the capacity controller, and these two against the ANOVA. The other three that I was going to put in here, I decided not to really bother with. I just want to concentrate on these. So let's go ahead and connect our pack up. This is really archaic, I know, but if I don't do anything stupid here, I won't have any shorts. But as you can see, I've got short circuit possibilities everywhere here. So I just need to be really careful. So let's connect up the capacity controller. Set that up. Oops, I keep going past it. Total voltage is 11 volts. Exactly 11 volts on that. I've got exactly 11 volts here. On these GT Power RCs, I've got 10.97 volts, 10.97 volts. That's very close. The final thing to test here is the ANOVA. And I'm blocking the reading there. .96. Well, that's pretty darn good, I think. That is, I think everything is pretty accurate. So I'm pretty happy with that. I think that's fine. If anybody else has any ideas on something that you think is a super accurate meter that doesn't cost $1 zillion, write it down in the description and pardon me, the comments, and let me know, and I might just pick up something like that if I know that it's really accurate. So this was a success. So I need to shut this off now before I do anything else, because if I have a short circuit, it's going to blow the fuses in the battery, and that's going to be a lot of work to replace those. So now let's move on to the final part of this video, and that's the two auxiliary batteries. Okay, according to my notes here, both these battery packs were fully charged. The 4S pack was 1657 and the 3S pack was 1232, and I connected these things up and left them for a week. I did go ahead and cut the wires on this 2 days ago because I forgot about this. I got busy at work and kind of forgot about it for a few days, and when I checked it, the voltage reading on this was well below what it should have been. Being a 4S pack, it should be dead at 12 volts. So let's connect it up here. And as you can see, it's showing 10.7. It was actually down to 8 volts. So that would have been 2, 4, 6, 8. That means that each cell got down to about 2 volts. So I don't know if it's damaged or not. It has came back up, but I don't want to leave that connected. So yeah, I put in this nice little handy 22 gauge butt connector, which seems to be good. So we got that connected up. So this one didn't last long, even being a 4-cell pack. This one really failed. What I'll do is go ahead and check it with the ANOVA here real quick. But I'm sure that is very accurate. Let's connect this back up. .56, 10.5. So yeah, hopefully this one isn't ruined. I will put this on the iMax B6 as soon as I close this video and let that charge up the next for the rest of the day. Okay, now let's look at this one. I did the same exact thing for this, and where is my connection at? Oh, okay, it's over here. So same exact thing. I just cut the ground wire and put that in there. So this one is 11.1, so that's not even showing dead yet. So this one fared a lot better, and maybe the cells in the 4S pack are just done. I don't know. 11.14, 11.1, so that's good. So I will charge up both of these, and hopefully this one is still good. This one apparently is still good. So I got a week's worth out of them. Actually, a week's worth out of this, and only 5 days out of this. So this one is probably not going to last me very long. But I would like to use it as an auxiliary battery. So we'll get that charged back up and then let it sit for a couple of weeks, because I have no use for it right at the moment. And same thing with this one. We'll get those charged back up and let them sit till I'm ready to do some other fun filled lithium battery and solar type things. So that is it for now. Hope you enjoyed this little meter comparison video. I sure did, and we'll come up with some other ideas to do here. Thanks for watching.